All right, let's talk about a big one from calculus, Lagrange's mean value theorem. I know, that name sounds super intimidating. But trust me, by the end of this, you're going to see that it's basically just common sense wrapped up in some fancy math language.
So to get started, let me just ask you a simple question. Picture this. You're on a road trip. You drive exactly 100 miles, and it takes you exactly 2 hours. Simple math, right? Your average speed for that whole trip was 50 miles per hour. So here's the real question. At any single moment, did your speedometer's needle ever land precisely on 50?
You know, your gut feeling is probably screaming, yeah, of course. I mean, you had to speed up to pass the truck, you had to slow down for traffic, so to make it all average out to 50, you must have been going exactly 50 at some point. Well, guess what? Your intuition is totally spot on. And the mean value theorem? That's the official ironclad mathematical guarantee that proves you're right.
Okay, so how do we take this pretty simple road trip idea and actually turn it into math? Well, it's all about shifting our perspective a little bit. We're going to go from thinking about speed and miles per hour to thinking about slopes on a graph.
Think about it like this. If we were to graph your journey with time on one axis and distance on the other, your average speed is just what mathematicians call the slope of the secant line. All that means is a straight line drawn directly from your starting point to your final destination. The steepness of that line, that's your average speed.
So that secant line, that's the big picture, right? The story of the whole trip. But what about that single moment you glance down at the speedometer, your instantaneous speed? Well, on the graph, that's something different. That's the slope of the tangent line. It's the slope of the curve at one very specific single point in time.
All right, now that we've got the intuition down pat with our road trip, let's look at the official guarantee itself. This is the mean value theorem, formerly named for the mathematician Joseph Louis Lagrange.
Now, this might look super formal and kind of intense, but I promise you it is just our road trip analogy in its official math close. All it's saying is that for any smooth, unbroken path, there has to be at least one spot where the instantaneous rate of change, our tangent line, is exactly the same as the average rate of change, our secant line. In other words, your speedometer had to match your average speed.
But, like any good guarantee, there's some fine print. For this whole thing to work, our journey, or our function in math terms, has to follow two really simple rules of the road. And honestly, they're pure common sense.
Rule number 1, the function has to be continuous. We can just call this the no teleporting rule. Your car can't just poof, vanish at mile 10 and magically reappear at mile 20. The path has to be connected. And rule number 2, it has to be differentiable. This is the no sharp, jagged turns rule. The path has to be smooth. You can't just come to a dead stop and instantly reverse direction. It has to flow.
So, as long as you play by those two rules, no teleporting and no impossibly sharp turns, the theorem gives you an unbreakable promise. Somewhere, at some point on that trip, your speedometer had to show the exact same number as your average speed for the whole journey. It's not a maybe, it's a mathematical certainty.
Okay, but before we get into why this is such a huge deal, let's just quickly talk about that word mean. It feels a little weird, right? I mean, what's so unkind or cruel about this theorem?
Well, this is just one of those classic cases where math hijacks a word we use every day and gives it a totally different meaning. When you and I say mean, we think unkind. When a mathematician says mean, they're just saying average.
So seriously, you can just mentally rename it. Don't think of it as the mean value theorem. Think of it as the average value theorem. It makes so much more sense. It's all about guaranteeing that an instantaneous value hits the overall average. Not so mean after all, huh? So you might be thinking, okay, that's a cool little brain teaser about a road trip, but why does this actually matter? Well, this is way more than just a neat math trick. This idea is a fundamental pillar that holds up a huge chunk of calculus.
It really is a cornerstone because it builds this rock-solid bridge between the big picture view, the average change, and the tiny in-the-moment snapshot, the instantaneous change. But its real superpower is that it's an existence theorem. It gives us this profound guarantee that a point exists, without ever telling us where to find it. And that ability to prove something is real and true without having to pinpoint it is an essential tool that lets mathematicians prove all sorts of other massive theorems.
When you boil it all down, the mean value theorem is about connection. It's the ultimate guarantee that links the entire story of a journey to one single, perfect, representative moment in time.
And that leaves us with a final, really fascinating thought to chew on. If we can guarantee this link for something as simple as speed, where else does it apply? Think about the average growth of a company's stock over a year, or the average rate of a melting glacier over a decade. The theorem says that at some single specific moment, the rate of change was exactly that average. It's an incredibly powerful idea that has massive implications, far, far beyond just a trip down the highway.